Morning, all of you students. Yesterday we have discussed how to check differentiability by using the graph. Look at the next concept. You will be given an equation in f of x. Look at. If you will be given an equation if f of x is satisfying such type of condition, f of x plus f of y for all xy belongs to R, if f dash 0 equal to 2, he will ask about derivative at some point. Find f dash 3, let us say. Right? So you will be given an equation. Look at here. For all these things, basic formula for derivative is at any point x, f dash x formula is limit h tends to 0, f of x plus h minus f of x divided by h. Look at this is change in y divided by change in x. At any general point f dash x you have to calculate means use this formula. At any particular point means you will find out f dash 0 plus f dash 0 minus like that. At any point x, this limit is called derivative at that point x. Suppose if you want to find f dash 1, x is 1, f of 1 plus h minus f of 1 divided by h. At any point, suppose derivative function if you want to calculate, limit h tends to 0, f of x plus h minus f of x divided by h. This is the formula. Then another alternate definition is at any particular point, limit x tends to a, f of x minus f of a divided by, this you can write at any point. Right? Suppose if this limit you got like this, look at f of x minus f of a divided by x minus a, x minus a. This is nothing but this is change in y divided by change in x, and this x minus a tends to 0. This is nothing but derivative definition only, f dash a. If you got the limit like limit x tends to a, the difference f of x minus f of a divided by x minus a, change in x. You got like this, then you can write f dash e. Suppose example it is like this. Number of times you will get this. Limit h tends to 0, f of h minus f of 0 divided by h, let's say. Look at this. So f of x minus f of a divided by h minus 0 is there. So x tends to a, h tends to 0. This is nothing but f dash 0. F dash 0 like this. If you got, whenever you got f of h minus f of 0 divided by difference of this h minus 0 as h tends to 0, f dash 0. Suppose you got like this. Or this is the one, look at like this. Suppose you got just like limit x tends to 1, f of x minus f of 1, change in y divided by change in x as x tends to 1. This is nothing but f dash 1. Like that. Whenever you want to calculate f dash x, that means at all x, you use this formula. Suppose this type of limit you will get in the problem. That is nothing but f dash a. Look at this. So this function is satisfying this condition. I want to evaluate f dash x. This is problem regarding derivative. I want to evaluate f dash x. Use that basic rule. Limit h tends to 0, f of x plus h f of x divided by h. So this we are applying for h limit. That means x is constant inside. H is the variable. So now use this rule. F of x plus y is given. Right? So in this is y, this is x, this is y. Use that rule. It is satisfying this condition. Limit x tends to 0. F of x plus f of y is h minus f of x divided by h. F of x cancel. That means you got limit h tends to 0, f of h divided by h. Look at this limit. So in the given equation, I am substituting x equal to 0, y equal to 0. On both sides, I am substituting x equal to 0, y equal to 0. Then what I will get? F of 0 equals to f of 0 plus f of 0. That means f of 0 equal to 0. That means f of 0 is what? 0. Now look at this limit I am writing. Limit h tends to 0. F of h minus 0 you can write divided by h. That means limit h tends to 0. F of h minus f of 0 divided by h minus 0. F of x minus f of a divided by x minus a. This is what? F dash 0. F dash 0 according to definition. That means f dash x is what? F dash 0. F dash 0 is what? 2. That means f dash x is always 2. What is asking? F dash 3 is nothing but 2. F dash 3 is nothing but substitute x 3. That means this is constant always. So f dash 3 is what? 2. Like that, if any relation is given, first you try to find out f dash x. You got f dash 0, that value will be there. Then you will get f dash x function. Then you can write whatever he is asking. So for this type of equation, you can use this formula also. This is direct method. If you want to use formula, look at formula is direct method. Directly you remember this formula. F of y for all xy belongs to R, then f of x equals to ax. Function will be like this. F of x equal to ax, right? You can use this one, ax. Now look at here. So ax, suppose the same problem is there. The same. Look at ax. You substitute here. A into x plus y. F of x plus y is what? A into x plus y. This is ax plus ay, satisfied na function. So you can proceed like this also without doing all these things. So you take f of x equal to ax, given f dash 0 equal to 2. Take this, you have to find a. F dash x is what? A. Given that f dash 0 equal to 2. So f dash 0 is what? A. That is given 2. That means a is what? 2. That means f dash x is what? F dash x is always 2. That implies f dash 3 is what? 2. This, now f of x you will get. Suppose f of x is what function? 2x. Suppose if you ask f of 5, what is that? 2 into 5, 10. Like that. This we will take this and find a by using the condition this is given. So that means f dash x you got, f dash 3 is 2, f of x you got, f of 5 is just 10. Like that, for this standard function, remember the formula. If you don't know the formula, you have to approach like this. Suppose. Next, another type of functions will be there. If f of, look at, very important, divided by n. Suppose if a function is satisfying like this relation, plus or minus f of y divided by n for all xy belongs to R, where n belongs to natural number and n greater than or equal to 2. Greater than or equal to 2. Then f of x equals to ax plus b. Function will be like this. Ax plus b. If n equal to 1, this is the one. Then ax. If n is 2, 3, like that, if it is there, function is ax plus b. Ax plus b. Look at. If suppose it is given like this. If f of x plus y by 2 equal to f of x plus f of y by 2 for all x comma y belongs to R, comma f of 0 equal to 1, f dash 0 equal to 2. Like this given, f dash 4 equal to dash, f of 3 equal to dash. Take this problem. Take this problem. Right? So now f of x plus y divided by n equal to f of x plus f of y divided by n. Take the function in the form ax plus b. Ax plus b. Now two informations are given here. F of 0 is what? F of 0 is b. So that is 1. That implies b is 1. Now find f dash x. F dash x is what? A into 1 plus 0. A. Given that f dash 0 equal to 2. F dash 0 is what? Put 0. A. This is given to. Now you got a b. A b. That means f of x equals to. F of x equal to what is the function? 2x plus 1. 2x plus 1. And f dash x is what? 2. F dash x is 2 means f dash 4 is what? That is also 2. Now suppose if you want f of 3. F of 3 is what? 2 into 3 plus 1, 7. Like that. Directly for this model and this model, you remember the type of function, how it is. And then by using the conditions, find AB. Look at question will be asked like this. Let F maps R to R. Let F maps R to R, comma, it is satisfying this condition. Belongs to R. Then options given like this. F is differentiable. D means differentiable. Only question is asked like this. In a finite interval. In a finite interval containing 0. First option is given like this, containing 0. So second option is continuous for all x belongs to our second option. Third option, f dash x is constant for all x belongs to R. Multiple correct answers. F is differentiable. F is differentiable except at finitely many points. Finitely many points. Look at this. So just now I have discussed. So if this type of function, how it will be? Ax. How it will be? F of x equal to ax. So this function, this is ax means line. Everywhere continuous. Ax means what? Line. So there will be no break. Continuous for all x belongs to R. Comma, differentiable, also differentiable at all points. Domain is R given, right? Because f dash will always exist. If you find out f dash x, what is that? A, constant. So that means, look at here. What he has given, f is differentiable only in a finite interval containing 0, not in finite interval. It is differentiable everywhere. This is wrong. He is telling it is differentiable only in an interval containing 0, right? This is differentiable everywhere. That means this is wrong. F of x is continuous. C means continuous for all x belongs to R. This is correct. F dash x is constant. F dash x is what? A, constant. So next, f is differentiable except at finitely many points. That means he is telling that at some points it will not be differentiable, but it is differentiable everywhere. So this is wrong. So those are the correct answers. Function is this. This is continuous and differentiable for all values. Derivative is a. If this is 2x, f dash x is what? 2. At any point it is 2. So this is, and this is correct. So remember this whenever you got. Suppose here by 3 equal to f of x plus f of y by 3. Then also same ax plus b. Continuous everywhere, differentiable everywhere. Next question. If f of x plus y equal to f of x into f of y comma f of 0 not equal to 0 for all x belongs to R, then number one, first one is f dash x equals to f dash 0 into f of x. For this type of function, derivative formula is f dash x equal to f dash 0 into f of x. Number two, f of x is a power x, a greater than 0. Look at this. Look at this. So first, how to find f dash x, we will see. Look at f dash x definition is what? Limit x tends to 0. Always proceed with definition. F of x plus h minus f of x divided by h. Now use this rule, f of x plus y. Y is h. Limit x tends to 0. So f of x into f of h minus f of x divided by h. F of x divided by h. This is x plus y. I have written the formula. That means now I am taking common. I am taking from these two f of x. I am taking common. F of h minus 1 divided by h. So now this is limit h tends to 0. F of x is constant. So f of x you write outside, constant outside the limit, limit h tends to 0, limit h tends to 0, f of h minus 1 divided by h. Look at this. So now in the given equation, you substitute x equal to 0, y equal to 0 on both sides. On both sides, that means you will get f of 0 equal to f of 0, f of 0 into f of 0. That means f of 0 will get cancelled. That implies from the given equation f of 0 is what? 1. F of 0 is 1. So that means f dash x is nothing but, so this is f of x. I am writing f of x, limit h tends to 0, f of h minus, this is what? F of 0 divided by h minus 0. What I told, f of x minus f of a divided by x minus a. That means that is nothing but into, this is f dash 0. This is f dash 0. That means derivative is nothing but f dash 0 into f of x. F dash 0 into f of x. Derivative means formula is this. From this function, if you calculate, you will get a power x. Remember this formula. From this calculating, you will get in differential equations chapter. For the time being, f of x is a power x. You remember the formula. Remember the formula. Derivative formula is this f dash 0 into f of x, and f of x is a power x. From this calculating f of x, you don't have now. For the time being, remember that formula. Was like the problem will be asked like this. Look at, problem will be asked like this. If f of x plus y equals to f of x into f of y for all xy belongs to R. Given equation this, if f of 4 equal to 6, comma, f dash 0 equal to 3, find f dash 4. He will ask like this problem. So now derivative you want. Derivative means what? Formula f dash 0 into f of x. F dash 0 into f of x. Now what you want? F dash 4. That implies f dash 4 is nothing but, in place of x you substitute 4. So f dash 0 is what? F dash 0 is 3 into f of 4 is 6. That means 18 is your answer. Like that. If you don't remember the formula, you calculate. According to definition, you calculate. This is standard one. You can remember the formula, otherwise you calculate like this. Always standard ones, you remember the formula. That will be easy in the exam. Okay. Next formula is, suppose if it is given like this. If f of x by y equals to f of x minus f of y for all xy positive, for all xy positive, then you remember this formula. k log x to the base c. Remember the formula. If suppose if it is given like this, f of x into y equal to f of x plus f of y for all xy greater than 0. If it is given like this, then same formula. K log x to the base c. Okay, remember these two formulae. Look at problem how we'll ask. If f dash 1 equal to 6, what he is asking is f dash 2 equal to dash f of e square equal to dash. F dash 2 equal to dash f of e square equal to dash. Suppose look at. So now function, you know the formula. You know the formula now. F of x equal to what is the formula? K log. Take this formula. Now use this condition. F dash 1 is given 6. You have to find k. So f dash x is what actually k into log x derivative is 1 by x. Log x derivative is 1 by x. Now substitute 1. K by 1 is what? K. That means k is 6. K is 6. That means if you substitute k, 6 log x to the base e. That means f of e square is nothing but so to write outside 12 into log e to the base e is 1. So f of e square is what? 12. Now he wants f dash 2. F dash x is what? This is 6 divided by x. So therefore f dash 2 is nothing but 6 divided by 2. 3. Like that. If you find k, you will get everything. Like that, these two formula you remember. Whenever equation is given, you take function in this form and then find k and then remaining whatever he is asking. Look at one more formula is there. Look at. These are all proofs, not necessary. Differential equations you will get. F of if suppose a function is like this, f of x plus y equals to f of x plus y divided by 1 minus xy, or it is satisfying like this, f of x minus f of y equal to 1 minus xy, any of the equation like this, then formula is f of x equal to k tan inverse x. K tan inverse x formula is. Look at. Problem he will ask like this. Look at. This is 3 given, this is 3. Then suppose take this problem. So he has given this equation, immediately that formula f of x equal to k tan inverse x. So k you have to find out. K you have to find out. Given this limit, that limit, now look at in the given equation you substitute x equal to 0, y equal to 0. So if you substitute, you will get f of 0. This is also f of 0. That means we can say that f of 0 equal to 0. F of 0 equal to 0. Now this limit is given. What is that limit? You can write this limit as minus 0 means f of 0 divided by h minus 0. This is given 3. This is given 3. Indirectly what is given? F dash 0 is 3. Without giving directly like this, he has given this limit is 3. That is nothing but f dash 0. So look at f dash x, I am finding out. Constant is k into derivative of tan inverse x. You remember the formula. 1 by 1 plus x square. Derivative of tan inverse x is 1 by 1 plus x square. You will get in the next chapter. If you know, if you don't know, remember. This now f dash 0 is 3, you know. F dash 0 is nothing but k divided by 1 plus 0, k. That means k value is what? 3. Therefore, f of x is nothing but 3 tan inverse x, comma, f dash x is nothing but k equal to 3 by 1 plus x square. Now what do you want? F of root 3. 3 tan inverse root 3. 3 into tan inverse root 3 means what? Tan pi by 3. Tan inverse tan pi by 3 is what? Pi by 3. So first one you got. F of root 3 you got. Then f dash 1. Substitute here x equal to 1. X equal to 1 means f dash 1 is nothing but 3 by 2. 3 by 2. Like that, just formula. By given condition, you calculate k. If you calculate k, everything you will get. Like this, for these type of functions, you remember the formula. For some equations like this, you don't know the formula. How to approach for finding f dash x, I will tell. Okay. Some problems will be there where you don't know the formula. Hmm. 3 into pi by 3. Okay. Look at next. Some equations will be given like this. Look at. Suppose equation is given like this. Two xy minus 1 is asking f dash 2. F dash 2. You don't know the formula for this. This is not standard form. So we will apply the basic procedure. F dash x definition is limit h tends to 0, f of x plus h divided by h. Divided by h. Now, this is y. H is y. Substitute y equal to h. Limit h tends to 0. Minus f of x divided by h. F of x got cancelled. So now, this I am writing limit h tends to 0. This f of h and minus 1 I am clubbing divided by h plus 2xh divided by h. H cancel. That means this is nothing but limit h tends to 0 plus there is no h. That means limit of h tends to 0, 2x is 2x only. Now if you look at this one, so in the given equation put x equal to 0, y equal to 0. In the given equation put x equal to 0, y equal to 0. What you will get? This is 0. So you will get f of 0 equal to 1. F of 0 equal to 1. Come here. Limit h tends to 0. F of 0 is this plus 2x. That means according to definition, f of x minus f of a divided by x minus a. That is nothing but f dash 0 plus 2x. So given f dash 0, that means we got the f dash x formula. F dash 0 is what? 2 plus 2x. That means for this type of function f dash x is what? 2 plus 2x. What is asking? F dash 2 is nothing but 2 plus 2 into 2. That means 6. Like that, if you don't know the formula, follow with this procedure and then evaluate f dash x. Look at one more model. Be a differentiable function. Be a differentiable function such that this is the equation given for all xy belongs to R, then So this is clearly regarding the derivative. Write the basic formula. H. So look at x plus 2y is there. You write this as 2 into h by 2. Right? So this take it as y. This take it as y. That means that is what? X plus 2y. F of x plus f of 2 into y. 2 into h by 2 h plus 4 into x into h by 2 minus, this is same f of x divided by h. So this f of x will get cancelled. So now what I am writing is f of h divided by h plus, this is, look at 2 ones, 2 twos. 2xh divided by this, that means this is 2x. This is 2x. Now you can observe in the given equation x equal to 0, y equal to 0. In the given equation, if you substitute x equal to 0, y equal to 0, so that means you will get f of 0 equal to 0. F of 0 equal to 0. So that means this is nothing but this limit. This is f dash 0 plus 2x. Now he is asking f dash 1. 2. So that means f dash 0 is nothing but f dash 1 minus 2. So that is the answer. Okay, one more model. Let f be a differentiable function such that divided by f of y for all xy belongs to r minus 0, comma f of y not equal to 0. It is defined like this. If f dash 1 equal to 2, then f dash x equals to a. Look at this. Right? So now clearly you have to find derivative. Write the formula H. But here f of x by y is given. F of x by y equal to f of x divided by f of y. For using that, what I am doing is, I am taking f of x common. F of x common. Right? So now it contains no h right outside f of x. Limit outside. This is just like f of x divided by f of y. F of x divided by f of y can be written as f of x by y. Used from this side. Divided by h. Divided by h. Right? Now if you observe from the given equation, put x equal to y equal to 1. Put x equal to y equal to 1. Right? If you will get f of 1 equal to f of 1 divided by 1. That means 1. So what I am writing is f dash x equals to x by x1 minus this is f of 1 divided by h. Actually f of x minus f of a. What is x minus a? Look at 1 plus h by x minus 1 is what? H by x. That means in the denominator h by x must be there. I have multiplied and divided. I have multiplied and divided. So now this limit f of x minus f of a divided by h by x, that is what? This limit is completely till here, this limit. That limit is what? F dash 1. F dash 1 divided by x. This x is constant. So x, that means f dash 1 is given what? 2. That implies f dash x is nothing but 2 f of x. Into this is f dash 1 divided by x. So f dash 1 is given 2. That implies this is given 2. 2 into f of x divided by x. That is the answer. So D is correct answer. Like that. Like that, if you don't know the formula, approach with the basic procedure. F dash x. We will go to the next concept. These are the models when an equation is given and you have to find f dash x. Look at next concept. Suppose if the equation will be given like this, look at. If f of x satisfies, suppose an equation is given like this, modulus f of x minus f of y less than or equals to modulus x minus y. Inequality he will give modulus x minus y whole power n, where n belongs to capital N, comma n greater than or equal to. Such type of inequality he will give. For all xy belongs to R, one equation is given. Then number one. Remember these points. I will tell how you got. F dash x equal to 0 for all x belongs to R. F dash x is everywhere 0. Number 2. F of x is k, constant function. F of x is constant function. B is continuous, comma differentiable. Obviously, if it is constant, it will be continuous and differentiable everywhere. Look at, always remember when such type of inequality is given, derivative at any point is 0, f of x is constant function, it will be continuous and differentiable. Look at, we will take an example and we will see this, how you got. Suppose take one example. If f of x satisfies suppose it is asked like this. Now I am using that shortcut, look at here. And after that I will do. Shortcut is what, f dash x equal to 0. At all points it will be 0. F dash x equal to 0 means put x equal to 4. Anywhere it will be 0. F dash 4 equal to 0. Now f of x is constant. That means given that f of 3 equal to 4. F of 3 here is what? K. That means k is nothing but what? 4. That means f of x is always 4. Is always 4. That implies f of 5 is what? 4. What is the answer? F dash 4 0 plus 4. That means 4. F dash 4, this will always be 0. F of 5, this value only constant. So 0 plus 4. Look at how. So take this. Look at that, x minus y whole square. I am writing modulus of x minus y whole square. This and this are same. Modulus square means what? Plus or minus square means you will get same thing. Here 1 modulus x minus 5 I am bringing to left hand side. 1 modulus x minus y I have brought to left hand side. Now I am applying both sides. I am applying both sides. Limit extends to y. Limit extends to y. If both sides I am applying limit extends to y. Modulus x minus y. Limit extends to y. So if you look at here, limit extends to a, f of x minus f of a divided by x minus a. According to definition, that is what? F dash a. That means modulus a is what here? Y. So modulus f dash y this is. According to definition, modulus f dash y. If you substitute x equal to y, this will become 0. Modulus f dash y less than or equal to 0. But this is left hand side is modulus. Na? Modulus cannot be negative. So that means therefore, as modulus cannot be negative, definitely that modulus must be 0. So that means f dash y is what? 0. Replace y equal to x. F dash x is what? 0. F dash x is always what? 0. That means if f dash x is 0, f of x is constant obviously. Derivative when it will be 0? If f of x is constant function. Like that, whenever the equation is given like this, x minus y whole power n, then you have to remember derivative is 0 and then f of x is constant function. If it is constant function, it will be continuous and differentiable everywhere. Look at next. Look at another statement. Another statement. If f of x satisfies modulus f of x, it is given like this. Modulus f of x less than or equals to x minus a whole power n. That side factor is x minus a whole power n. Whole power n for all xy belongs to, for all x only. For all x belongs to R, for all x belongs to R and n belongs to n, n belongs to n. You take here modulus x minus a whole power n. N belongs to n, comma, n greater than or equal to 10. Only x is there. Here x minus a factor is there. Then the theorem is f dash a equal to 0. At this point a derivative will be 0. Look at this point is there x minus a. At that point derivative will be 0. Number 1. Number 2. F of x is continuous and differentiable. at x equal that point. You can say if this type of equation is there, that will be differentiable at x equal to a. At x equal to a. Look it. I will tell an example for this. If modulus f of x less than or equal to x square for all x belongs to R. For all x belongs to R, then look at the options. A, f is continuous for all x belongs to R. F is continuous at x equal to 0. F is differentiable for all x belongs to R. F is differentiable. This is like this given. Shortcut how to use the above theorem is modulus f of x. We write like A is what? 0. A is what? 0. What the theorem states? Above theorem, f is continuous at x equal to 0. F is differentiable at x equal to 0. You cannot say for all real numbers. I will tell, look at, look at. Let us discuss this problem. So look at, this is given like this. So modulus this x square, I am writing it as modulus x square. X square is nothing but modulus x square. So now I am bringing one modulus x this side. Less than or equal to modulus x. Now in the given equation, substitute x equal to 0. In the given equation, substitute x equal to 0. What you got? Modulus f of 0 less than or equal to 0. But modulus cannot be negative, therefore is 0. That means what? F of 0 is 0. From the given statement, you can say that f of 0 is 0. Now take this one. Take this one. I am applying limit extends to 0 on both sides. Modulus x limit extends to 0 on both sides. If you look at this left hand side one, you can write this as f of x minus f of 0 is 0. This is what limit 0. This is limit is 0. What you got? This if you look at limit extends to a f of x minus f of a divided by x minus a. That means modulus. This is nothing but according to definition modulus f dash 0 less than or equal to 0. But here modulus cannot be negative. That implies what? F dash 0 equal to 0. That means derivative is 0 means what? F is differentiable. F is differentiable at x equal to 0. If it is differentiable, F is continuous, obviously. If the derivative exists, that means it is continuous only. That means this you can say. Remaining points we cannot say. From this given one, we can say at 0 it is 0. Remaining points we are unable to say by using this condition. So that's why only at single point you can say. You cannot say whether it is continuous or not. You cannot say whether it is differentiable or not for the remaining numbers. But at x equal to that point, that a, at that a, it will be continuous and differentiable. Remember this theorem. Suppose if the question is like given like this, look, if modulus, suppose question can be asked different number of ways. If modulus f of x less than or equals to x plus 1 whole cube. For all x belongs to R, then what can you say? Then f is continuous comma differentiable. So this is nothing but x minus of minus 1 whole cube at what? X equal to minus 1. At x equal to minus 1, it will be continuous and differentiable. And what can you say about f dash minus 1? 0. F dash minus 1 will be 0. Next application on this model. P of x is a polynomial given like this. Less ai are real numbers means a0, a1, a2 and so on. An are real numbers and n is a natural number. So this is a polynomial given. Let P of x equals to, if modulus P of x less than or equals to modulus P of x less than or equals to modulus of e power x minus 1 minus 1 for all x greater than or equal to 0. This is one inequality given. Then maximum value of modulus a1 plus 2a2 plus 3a3 and so on plus n into an is a, b, e. Look at this model. So P of x is a polynomial given and he has given that it is satisfying this inequality. Then maximum value of this. First, what he is asking, if you identify this, it is related to derivative. It is related to derivative. Now I am finding P dash x. Look, P dash x constant 0, a1 into 1 plus a2 into 2x, a3 into derivative 3x square x cube and so on. Last one is an into derivative of x power n is n into x power n minus 1. Now if you substitute 1 here, p dash 1 is nothing but whatever he has given. In the modulus inside, this is inside is what? So p dash 1, that means he is asking maximum value of maximum value of you have to calculate maximum value of modulus p dash 1 equal to dash. That means this problem is regarding derivative. Now look at this inequality you take. Our target is to find p dash 1. This is given. I am substituting x equal to 1 on both sides. X equal to 1 on both sides. That means modulus p of 1 less than or equal to. This will become e power 0, 1 minus 1, 0. This, but modulus cannot be negative. That implies that p of 1 is 0. You can conclude that from the given inequality, we can say p of 1 equal to 0. P of 1 equal to 0. So now what I am doing is both sides I am dividing with modulus x minus 1. Divided by, I have divided with modulus x minus 1 on both sides. Modulus x minus 1 on both sides. So that implies I am writing this modulus minus 0 is there, p of 1 divided by x minus 1 less than or equal to modulus this. I am writing like this. Now I am applying limit extends to 1 on both sides. Modulus limit extends to 1. Limit extends to 1 on both sides. That means this is what, according to definition, this is modulus p of x minus p of a divided by x minus a. This, according to limit formula, e power x minus 1 by x, that is what? 1. That means 1. Limit is 1. Therefore, maximum value of modulus p dash 1 equal to what? 1. So, answer is B. Next. One equation is given like this. 1 plus sine 4x into g of x f of x is where g of x is continuous at x equals 0, then f dash x equals to, look at this. G of 0. So f is satisfying this condition and f of x is this. Then f dash x. F dash x by using the basic limit. This is the definition. This is the definition. That means f of x plus y is h. F of x into f of h minus f of x divided by h divided by h. So now f of x take common. F of x take common. H. So now f of x is nothing but, I am writing in like this, okay. Limit h tends to 0. Limit h tends to 0. F of x limit into limit h tends to 0 minus 1 divided by h. Minus 1 divided by h. F of x I am substituting. Look at f of x I am substituting, that is given. One plus sine 4x so this has no h. That means the f of x only. This is no h, na constant, into limit h tends to 0. F of h substitute here. 1 plus sine 4h into g of h. So this is 1 cancel. 1 cancel. So that means I am writing here, look at f dash x equal to, this is f of x into this sine 4h by divided by h separate and limit h tends to 0, g of h separate. So f of x into multiply and divide by 4. Standard limit is 1. That value is what? 4 into. So given that g of x is continuous at x equal to 0. G of x is continuous at x equal to 0 means limit h tends to 0. G of h is what? G of 0. If it is continuous, limit value will be equal to g of 0. Therefore, f dash x is nothing but 4f of x into g of 0. 4f of x into g of 0. The reason for giving that g of x is continuous at x equal to 0 means this limit value will be equal to g of 0. Like that application of by basic definition of derivative. Look at next. Find the points of non-differentiability of modulus x square minus 1 plus modulus x plus 2. Modulus x plus 2. Suppose a function is given like that. Look at, we will do by two methods. Look at, here plus or minus, here plus or minus will be there actually. This sum function, how you have to write, I will tell. Look at, by opening the modulus, how to write sum function I will tell. After that we will see the shortcut for that. Look at, first this modulus has two definitions. First explore that. Equal to what I told, modulus f of x means when f of x less than or equal to 0, this, that means this will have the definition 1 minus x square. This is x plus 1 into x minus 1 less than or equal to 0. That means x belongs to minus 1 comma 1. In this interval it will have the definition 1 minus x square. Next, minus infinity comma minus 1 union 1 to infinity. In this interval it will have the definition x square minus 1. That means this is what you can write like this also, x less than minus 1 or x greater than 1. This is how to open the modulus. So in this interval this is the definition, in this interval this is the definition. Next, another modulus is there, explore that also. So this is minus of x plus 2 when x plus 2 less than or equal to 0, x plus 2. That means this definition will be minus of x plus 2. So depending on the interval, this definition will be, this definition will be. Now look at, you have to write this one. Let us take this as f of x. Now what I will do is, first I will explore the first one. Without changing this, I am writing the definition of this. That means when x lies between minus 1 and 1. When x lies between minus 1 and 1. This definition is what? In the next chapters also it will be useful when you open the modulus. So this is when, this is the definition. I have not changed this one. Just I have written this one. Next is when x less than minus 1 or x greater than 1. What is the definition of this? Written. Right? Now easily in this interval definition of this you can easily write. Look at, you know, here x less than minus 2, this is the one, x greater than minus 2, this is the one. Now minus 1 to 1 means where it will be minus 1 to 1, minus 1 to 1. If you take minus 1 to 1, where it is? X greater than minus 2. Minus 1 to 1 means it will be here. That means in this interval you can easily write that. What is the definition of this in this interval? X greater than minus 2, 1 minus x square. This is modulus x plus 2 is what? X plus 2. This is over. Similarly, x less than minus 1 I have to write. X less than minus 1 means here there is a problem. Look at x less than minus 1 means less than minus 2 there is one definition, and minus 2 to minus 1 there is one definition. That means you have to split this x less than minus 1 into two parts. That means minus 2 to minus 1, one definition I am writing. Look at, for this x less than minus 1, I am dividing this into two parts. Minus 2 to minus 1. I mean, no. X less than or equal to minus 2. I am dividing this. X less than or equal to minus 2 and x lies between minus 2 to minus 1. These both will become x less than minus 1. X less than or equal to minus 2 means here this is x square minus 1. This is what? This is minus of x plus 2. Here. This. So then minus 2 to minus 1 means here this is same. This is what? Minus 2 to minus 1 plus x plus 2. Oh, for x less than minus 1 I have written. Then x greater than 1. X greater than 1 means modulus x plus 2 is nothing but the same thing. X greater than 1, x plus 2. This is the complete definition. After opening this and this is the definition. Whenever you want to open the modulus, proceed like this. So what is this here? Minus x square. This is x square minus x minus 3. So now over. So this definition completely I have written. Now you have to check continuity and differentiability where at the points where f of x changes its rule. At what points here? What are the points visible? X equal to minus 1, minus 2, minus 1 and 1. There I will check. At x equal to minus 2. at x equal to minus 2, checking the derivative of, it will be continuous only obviously. Minus 2 plus greater than minus 2 is what? 2x. Next one, if you substitute minus 2, minus 3, that is f dash minus 2 plus minus 2 minus, this is the one. So minus 2 if you substitute minus 5, that means not differentiable at this point. So next is x equal to minus 1. X equal to minus 1, f dash minus 1 plus. Minus 1 plus means this is the one. That means, so minus 1 if you substitute, what you will get? 3. Minus 1 minus. Minus 1 minus means here. So if you substitute minus 1, these are not equal, not differentiable. These are not equal, not differentiable. Next point is x equal to 1. F dash 1 plus. 1 plus is what? This is the one. 3. 1 minus. That means minus 1. Therefore, not differentiable. At 3 points. Or otherwise you can do like this. Another method is, yesterday we have discussed. This function not differentiable where this function not differentiable where minus 2 over these 3 points. This, right? If you want to write the definition, you have to write in this way. In the next chapters, writing this definition is important. That means opening the modulus, in which interval which function is there, you have to write. Differentiability means just do like this in the exam. This equal 0, what is this? Plus or minus 1. This equal 0, what is this? It is not differentiable at this point, it is not differentiable at this point. So therefore, what is the answer? That only you got minus 2, minus 1, 1. Okay, thank you all of you. Have a nice day.